mentioned yesterday, the bulk of this chapter will deal with quadrilaterals and special quadrilaterals. Yesterday we talked about the measures of angles, interior and exterior of polygons. Today we're starting our discussion on parallelograms. Some of you already know what a parallelogram is. You know that it's a quadrilateral. What do you think a parallelogram is? Parallelogram. Absolutely. A parallelogram is a quadrilateral with two pairs of opposite parallel sides. Okay, make sure that you're clear on the vocabulary. Opposite sides are sides that don't share a vertex. So just for the sake of clarity, can one person please name for me in that parallelogram ABCD that I've drawn for you? Can you please name for me a pair of opposite sides? So AB and DC are opposite sides. What is the other pair of opposite sides? Michael? AD and BC, absolutely. Opposite angles don't share a side. Again, just for the sake of clarity, making sure that we're all talking the same language. Can someone else please name for me a pair of opposite angles in this diagram? Opposite angles. Yes, Trent. Angles A and C are opposite angles, as well as B and D. Fantastic. Consecutive angles of a quadrilateral share a side. Another way to think about it is that consecutive angles are the angles right next to each other. So, for example, pair of consecutive angles. One person, please. Grace. Angles A and B are consecutive angles. Okay, so I wanted to make sure that we're all talking the same language before we looked at a parallelogram and the properties therein. Okay, so notice the parallelogram that we have on our screen, and notice that while my measurements are changing, I would hope that you notice that relationships between them are staying the same. So what do you notice? And you have it in your notes. They have nice little blanks ready for you. What do you notice about the opposite sides of a parallelogram? Say that again, Lily. They're congruent, yes. How about opposite angles, like B and D? Here's angle, let me do this. There's angle D, angle B, C, and A. What do you notice about the opposite angles, ladies and gentlemen? They are congruent. How about consecutive angles? Are they congruent? Consecutive angles. Ooh, brilliant. Yes, they are supplementary. Fantastic. So let's come back to our notes then. Opposite angles are congruent. Opposite sides. I got that backwards. Matter, they're congruent too. Consecutive angles are supplementary. And what we couldn't observe in that parallelogram, because I didn't draw the diagonals bisect each other. And again, in the interest of making sure that we're all talking the same language, diagonals bisect each other. Does that mean that the diagonals are congruent? No. Can someone rephrase that statement, diagonals bisect each other, in plain old teenage speak? How would you explain it to someone that isn't here today? What would you tell them about the diagonals? Without using the word bisect. How? Okay, they cross each other. Is there anything interesting about the way they cross each other? Where do they cross each other? At each other's midpoints. Okay, so the point that I'm trying to get across is that the diagonals are cutting each other into congruent pieces. Okay? We have from this screen what we need? Okay, we start off, ladies and gentlemen, let's stay focused, please. We start off fantastically easy. Problem 1, what's the measure of angle R? I'm seeing calculators, so that's a good sign. Grace. 109. Measure of angle R is 109. For the sake of clarity, it's 180 minus that 71. That was painless enough. And then some of you are looking ahead and saying, no, but Mrs. Clouse, the pain is coming. I see the pain, Mrs. Clouse. I see it. Oh, it's not so bad. So I tried again, make it interactive. Also, I realized kind of after the fact that in order for everything to fit, you need to write the words, statements, and reasons above the chart, not in the chart that I've given you. So, yes, good, come on, click and drag. You know where it starts. That should be the one everyone volunteers for. Okay. So I have these parallelograms. Fantastic. Please also notice while I'm thinking about it, please notice the symbol parallelogram. So where do I go from here? I want to eventually prove that angle M is congruent to angle D. All I have is the knowledge that these are parallelograms, and remember all those properties that I just gave you 2 screens ago. So what can I do with that? What can I do with that? Look at our word bank. Any ideas on where to start? Sarah, go ahead. Tap away from up. You know what? You know what? Leave it there, because remember what I've said before, and it kind of applies in this proof also. As long as all the necessary pieces are there. And you know what? Let me give you a hint. Oh, goodness, that is so not what I meant to do. Come on. It's not behaving. Okay. I've given you a hint. Yes, Grace, go ahead. Now, be careful. Notice that the hint that I gave were that opposite angles in a parallelogram will be congruent. These are segments. Okay, so this would be something I would say if I was using opposite sides of a parallelogram are congruent as a reason. Michael? those are also opposite angles of a parallelogram. And once again, remember, you know the easy parts of a proof. You know where it starts. You also know where it ends. But why does it end that way? You know where the proof ends. Is that your hand? Kind of. She's got it. Absolutely, yes. If m equals, if m equals b and b equals d, then yes, m equals d, transitive property. Okay? Not too bad, not too scary. Okay, take a moment and work through the your turn for problem 2. It is also a proof. Okay, let me go ahead and get started on this because it's looking like we are stumped on statement 2. Notice the given. AK is congruent to MK. Look at the diagram. This is a triangle, ladies and gentlemen, in which two sides are congruent and then therefore, say that louder with conviction, Lily. Exactly. Remember, this is the isosceles triangle theorem. So far in this proof, what we've said that is kind of connecting where we're trying to go, so far we've said that this angle is congruent to this angle. Notice the hint that I'm giving you for statement 3. You're using the fact that opposite angles of a parallelogram are congruent. So what opposite angles of a parallelogram might be convenient to us here, Grace? Angle A is congruent to angle BCD. And the order is kind of off, but it's along the same lines as what we saw in the previous proof. Notice statements 2 and 3 both have angle A in them. Why, therefore, will angle BCD be congruent to angle CMD? I see it. Say it loudly with conviction. It's the transitive property, yes. Yes, ma'am. Transitive property, again, says at its simplest, if A equals B and B equals C, then A equals C. Okay? So what you needed to observe in statements 2 and 3 is that angles CMD and BCD are both equal to A. Therefore, they're equal to each other. Okay, we have what we need from this screen. In problem 3, they're telling us to solve a system of equations. Remember, this is an algebra skill. You've seen this before. What you need to observe in the diagram is that these A and B expressions are parts of the diagonals. Remember what the diagonals do. They bisect each other. So what equations am I setting up based on this diagram? One person, please. There's going to be 2 separate equations. What are they? What equals what? Casey. My copy quality up here is awesome. Is that plus A or minus A? 8. Good grief. My copy quality is awful. It's minus 8. Absolutely, yes. A equals 2B minus 8, and then tell me the other one, Casey? That's it. Okay, because this is a system of equations, and no one equation has only one variable in it, I have to use either substitution or elimination. Myself personally, I would hope that you're looking at these 2 equations and realizing that you have variables solved for, which means you can easily use substitution. Okay? So, just in the interest of getting it started, I'm going to take this value of b and substitute it in for b in the other equation. Again, remember, you've seen this before. This is nothing new. Don't panic. So all we're doing now is rewriting this top equation, but now I'm substituting in this a plus 2 wherever I see b. My new equation, therefore, will be a equals 2 times, do that again. A equals 2 times a plus 2, and then minus 8. And now notice we have one equation and one variable. You could solve that in your sleep. That was almost perfectly fine. Is that yellow? A equals 2a minus 4. So a equals 4. The problem, however, isn't asking us for either value of the variable. It's asking us for h, j, and ik. So we need to first figure out what b is, of course. B is a plus 2, so b is 6. And now look at the diagram. Look at the diagram. Yes, ma'am.
Is it a plus 2 minus 8?
Say that again, please.
A plus 2 minus 8.
Absolutely. However, notice that this segment right up here, eyes up, so you're looking at what I want you to notice. This segment right here is 4. See that much? Okay, remember, this is the part of the diagonal that got cut in half. So if this is 4, quickly, what's hj? 8. By the same token, notice up here that this little part of ki is 6. So quickly, what's ki? It's 12. Now, of course, if you didn't catch that observation and you went through the process of figuring out what a was and then figuring out what 2b minus 8 was and adding them together, you'd end up in the same place. Last thing, I gotta skip over the your turn. There's one last property, and it's wildly simple. If 3 or more parallel lines are cutting off congruent segments, whoa, that sounds really involved, and I don't see it, Mrs. Clouse, so I can't process it. So, of course, if these parallel lines are shown to me to be cutting off congruent segments on one transversal, then no matter what transversal I draw going through those parallel lines, it will also be cut off into congruent segments. Now please don't misunderstand. You'll notice I put 2 hash marks here versus 1 hash mark here. Eyes up, so that you see what I'm referring to. Please do not misunderstand and think that this segment will be congruent to this segment. Not necessarily. What I'm saying is that each transversal is being cut into equal parts. Okay? Because I'm told that this one is being cut into congruent pieces, I can conclude that any other transversal going through these parallel lines will also be cut into parallel parts. So, looking at the example that's given to me, notice how it's phrased. They're telling me that RS equals ST, and that these are parallel lines. They have given me that WV is 7. They're asking me for WU. Look at it carefully. What's WU? It's 14. Okay? Very easy to jump the gun and say, oh, I know VU is 7. Well, yes, it is, but that's not what you were asked for. You were asked for WU, which is 14. And we don't have time for a daily quiz today. We'll pick it up either tomorrow or the day after. Remember, the assignment isn't due until Thursday because tomorrow we're in lab 3.